Hi everyone, welcome back to our channel. In today's tutorial, we are going to explore the concept of tools in Open WebUI in more details. We'll be exploring the anatomy of your tool in detail. If you want to create a tool from scratch or to understand how an existing tool is configured, then this video tutorial is for you. It helps you a lot. So before going ahead, just a quick recap. So first you need to connect your main LLM. So here I'm using this OpenRouter.ai for using large language models. So I have given the API key and set up the connection here. So this is the fundamental prerequisite before going ahead. In this session, specifically, we are going to explore a standalone tool that lets us search this archive.org directory directly without using their official API. So this is a tool that we have written for this purpose. In this tool, we build the same advanced search URLs that archive website itself generates, and then we will scrape the results page. Okay, that's what we are grossly doing in this code, but don't worry, we will go into every detail of this code shortly. So before going ahead, so let's quickly test how it works and what can we expect from this tool. So let's open our Open WebUI. So these are the tools. So I have some existing tools here. I'm just deleting them. Okay, so right now I don't have any tools here. Let's add a tool. So here, check, we are in the tools tab and then click this plus button, click this new tool. So you will get a tool layout. So we don't need it, just delete. Copy this entire tool code and paste it here. So give it a name, archive search. So search archive directory. This is a simple description that I'm giving. So just click this save button and click this confirm. Okay, now your tool come here. So just open any new chart as usual. So here you have to click this function calling to native. Why this function calling to native? Because if you click this function calling to native, it uses this tool explicitly. Else sometimes it hallucinates and sometimes it may or may not use the tool if you set it to default. So if you open for the first time this chart, the function calling is always set to default. So you have to toggle it to native. Keep this in mind and then close this chart controls and then change the model. So I am choosing a model DeepSeek V3.1. You have to choose the model in such a way like it uses tools actually. Not every model is comfortable with tools. Only some models are specifically can use tools actually. DeepSeek models or Anthropic Cloud models, OpenAI's GPT models, and Gemini models. They are all comfortable with tools. You can use any of this model. So after that, you have to select your tool. I'm just selecting the tool, and then you can write any such you want that you wish to understand from the archive repository. So I'm asking like find all the pins papers published in 2024. So it is doing a search. See, your tool is running, executing archive search, and for the search, it is using these parameters. See, it has got many results. So these are a long list of results actually. So here, this is a tool that it used, and these are the search parameters, and these are the results it has got actually. So let's verify if these are correctly extracted or not. So let's copy this string and paste it here. So we used this advanced search. So let's paste it here and where to search. So search for all fields because that's what we have specified here, and mark the dates of 2024, date range 2024 0101 to 2024 1231, and then submission date, announcement date. So keep them default. And if you search it, the first paper is convergence of physics and formal neural networks for fully nonlinear PDEs, and this is the paper Avitic, and this is the paper by Avitic. And the second paper A Mishra, and here the second paper is by A Mishra. So like that actually. So you have got around almost many results, and here is the summary of all those things actually. So it did not show up all the details printed here, but you can find all the details here. Okay, and it gave a summary of what has been published in the year 2024 on pins. So if you look at here, so you just gave pins papers and what are pins actually. So the LLM model interpreted this pins as physics informed neural networks, and that is what I want. Okay, that same full form has been written clearly and published in 2024 on ArXiv. So it used the same year and dates also in a very exact way. Okay, so this is how your archive search tool is working. Okay, so let's explore this tool in detail. So this is the basic Python code that we have written for this tool. In this tool, we are doing the same thing that we did actually. So we will give a string and then we set this all fields and then we give a date range and then we specify the submission date as most recent and then search it. Whatever the results that come from here, we will scrape those results within our Python code. That's what we are doing grossly in this code actually. And we are not using any archives API. We are just doing a search operation by building a search URL and then we are scraping the web page. So let's explore the details. So here these are some main important libraries that we need, and the most important thing is these libraries has to be installed using pip or conda or whatever the way you want. This has to be installed in the same environment where this Open WebUI is running. So make sure you have these things installed, and then here I am giving some keywords: archive base, advanced search URL, and simple search URL. So these are some keywords that I am giving for this URLs actually. This is the base URL, and after that this is a advanced search URL and this is a simple search URL. Here you see it, right? So if you go to, this is advanced search, and when you remove this, this is your simple search. So simple search doesn't take more details, and this advanced search will take more details, but you can use any tool that you want actually. And this is our main function area. So here you have two kinds of functions actually. One is the primary functions that actually does some work, like this archive search. This is our primary function. This is actually doing the work, and the remaining all functions, or whatever the functions that has this underscore before, they are all some utility functions. So these serve other functions for various purposes. Okay, so these are the kind of function organization that have made in this code actually. You have some utility functions that does some work, but they are primarily helping other main functions actually. For example, our first utility function is this text clean function. So what it does is, when we scrape a web page, the text often comes with messy spaces or HTML tags. So this function cleans it up all. It collapses extra spaces, decodes entities, and gives us a neat string that we can actually display to users actually. So that is what we do in this text clean function. Following that, we have this find all function. This is basically a wrapper around this Python's find all function. So the primary difference is we set some default flags here, and this is another function find one. Sometimes we just want the first match instead of whole list. So this function does that. If nothing is found, it safely returns none. You'll see this used when extracting optional fields like abstract or dates, etc. And next is our chunk results. So what it does is, so when archive shows such result, each paper is wrapped inside li tags actually. So this kind of tags you see everywhere. So this function simply slices the full page into separate blocks, one block per result card. So if you have 50 results on a page, we will get 50 blocks. We will get 50 blocks to parse actually. So like that, it basically trims off all these li tags and gives you a neat list of results. And the next one is parse one result. So this is our main function. So where all the above helper functions or utility functions that we have created above will be used here actually. This is our real workhorse. It takes one of those block that we have just got and carefully pulls out all the useful information like the paper title, abstract link, the list of authors, the full abstract text if available, the direct PDF link, the primary category, and also the submitted and announced dates actually. So basically it converts one raw HTML snippet into a clean Python dictionary. This is a building block of our final results actually. So this is our main function that does the real work. And after that you see this tools class, right? So this is the main class. So in Open WebUI your tool has to be enclosed in this tools class. So Open WebUI expects the tool to be wrapped in this format actually. So here you have a function, for example this parse one result. So even if you create this as a main function, Open WebUI doesn't treat this function as a tool actually. So for your function to treat as a tool, that has to be enclosed within this tools class. So this is the key important thing. And here comes the main thing. It is another class of user valves. Normally some tools require API keys. So OpenWebUI defines something called user valves to store this API keys actually. In this tutorial, ArXiv does not require any keys. So we are just keeping it here just to preserve this layout. You can delete it also, it won't be a problem. And then here I am defining this main init function. Here I am setting some key variables, self default order, default size, default date type, and some session. These are some key variables that I am defining. You can change if you want. So here we are creating this ensure session. So this is some intermediary session mainly used for web scraping. It adds a polite browser like user agent header. So ArXiv does not think like you are a bot. It also applies a timeout for safety. And then here is our fetch function. So if you look at here, these functions are enclosed in this async because these functions will take some time to execute. Okay, so because of that, we created this function under async. Async means so whenever you see this await within this async, so it waits until this particular line is executed. It won't move beyond that until that particular line is executed actually. So for this purpose, we are using this async keyword here. And then here we are building our main advanced search URL with all the search parameters that we have defined above. This is one of the most important parts. It constructs the exact search URL the advanced UI would generate. We pass in query, date range, search field, order size, and start index. So the result is a URL like what you would see in the browser if you did the same search manually. For example, if you do all these things and then if you do give some dates and if you click this search URL, you see this URL, right? So this is the main URL with all the search parameters that you have just given. After building the URL, here is our main function archive underscore search. So this is the main entry point. This is the function that Open WebUI calls actually whenever we ask to do some search operation. You can see it here, archive search function, and that is this function. So we give it inputs like query text and from and to dates, the field to search in, the date type, order, page size, and the maximum number of pages. All these variables we pass as a function arguments. It loops through pages, builds the URL, fetches the HTML, then chunks it into result blocks using all these helper functions that we have just written above. Each block is parsed using this parse one result and we assign a rank number so that the order matches what you'd see on the website. You've just seen, right? So our search is exactly same as the one that you see on the website actually. So the order of this search results and the order that you see here, they're basically same, and that's what we are doing here, and we get this order by assigning some rank to it. So in the end, we are bundling everything into a detailed summary dictionary that includes the query parameters, how many pages were fetched, and all the details actually. So every result will be go into this dictionary. So in the end, we are writing this close function. So this is where we shut down the HTTP session. So this is a good practice. It prevents resource leaks and ensures your script is polite to the server. This is a full detailed walkthrough of Open WebUI tools. So basically, a tool has two main things. One is the helper functions, and the other one is the main tool function. And whatever the tool main function, that has to be enclosed within this tools class. So then only this Open WebUI considers that tool and executes when needed. That's it. This is a lightweight tool. So API free. You don't need any API keys. You can just use it whenever you want. If ArXiv changes their HTML in the future, we may need to tweak this code to match the regex patterns, but the overall logic will remain the same. So that's it for this tutorial. So you can ask any questions here actually. So just turn on the search and make sure the function calling is set to native and ask any questions that you want to find the papers on say electromechanical coupling in 2023. So and give me a detailed summary of all the papers published. So let's ask some question. It is starting this search. So it has found so many papers. Let's go to top. It used electromechanical coupling and it has given 2023 dates and it has listed all the papers here. Let's see what summary it provides. So it is doing several searches. So let's see what is the difference between these search operations. Electromechanical coupling and some dates, and in the second search, so it is giving another search query, electromechanical coupling or piezoelectric MEMS. So MEMS is also involves electromechanical coupling, and this is the query and so on so dates. And in the third one, it gave another such string, electromechanical coupling and something else. It has found some more papers. So likewise, it called the tool thrice actually. So this I did not expect, and based on the search results, it found numerous papers on electromechanical coupling in 2023, and these are the main key papers on piezoelectric materials and devices and MEMS and NEMS technologies, computational modeling, and yep, this is what I expect actually. It gave some key findings in these papers. Seems like we have many categories. Energy harvesting and power systems. And the key findings are development of energy efficient harvesting from mechanical vibrations, improved methods for power system stability analysis, applications in renewable energy integration. So these are some key findings or key researches that was made in this category actually, energy harvesting and power system. And likewise trends and future directions. Some paper publications were on miniaturization, frequency scaling, quantum integration, biomedical sustainability, and computational advances. So overall, these is the summary of all the papers that were published in 2023 on electromechanical coupling. So the key thing that you wish to understand is, so we have given the tool once, okay, and it called thrice. So with three different such strings, okay. So not only thrice, depending upon the need, it can call any number of times actually. So this is how we have to create a basic tool in Open WebUI, and the LLM uses the tool in any which way it wants actually. Okay, so that's it for this tutorial. In our next tutorial, we will learn about tool server. If you have any questions or suggestions, feel free to ask them in the comment section. See you in the next tutorial. Happy learning. Thank you.